All right, let's get started. Today, we are tackling what I like to call a gold standard equation in a special masterclass from the John Louis Memory School. Now, I know it might look a little intimidating at first, but trust me, by the end of this, you are going to feel like an absolute chemistry champion. I promise. So, a huge, warm welcome to all of you joining us here at the John Louis Memory School. Like I said, we are taking on a masterclass in balancing chemical equations. I want you to think of this whole thing as a giant puzzle, and we're going to solve it together step by step. You've totally got this. And here it is. This is our puzzle for today. Now, this beast of an equation, it actually shows how gold is dissolved using cyanide, which is a really big deal in gold mining. I know, it looks super complicated, right? But here's the secret. This isn't the problem. This is the answer. This is our final destination, and we're going to build this entire thing completely from scratch. Our whole goal today is to figure out exactly how we get here. Okay, so first things first. How do you tackle a giant puzzle? Well, you break it into smaller pieces. That's our strategy, divide and conquer. We're going to split this big reaction into two little, much easier parts. So our first type of mini reaction is called oxidation, and I have a fantastic memory tip for you here. You're going to love this. Just remember the word oil, O-I-L. It stands for oxidation is loss, a loss. Say it with me, a loss. A loss of what, you ask? A loss of electrons. In our big puzzle, it's the gold, the Au, that is losing an electron. It's literally giving one away. Now, if oxidation is loss, what's the opposite? You guessed it, it's a gain. And that's called reduction. And we have another memory tip for this one. If you remember OIL, then you gotta remember RIG. RIG. Reduction is gain, a gain of electrons. So who's gaining the electrons that gold just lost? Well, it's the oxygen, the O2. It's taking those electrons in. So you see, we have one thing losing and one thing gaining. It's a perfect, beautiful balance. And check this out. This is what our divide and conquer strategy looks like in action. We've literally just broken that huge, scary equation into two simple puzzle pieces. You can see it right here. On the left, we've got our oxidation half, and on the right, our reduction half. Doesn't that already look so much easier to handle? Yeah, I thought so. All right, time to get our hands dirty. Let's start balancing these two halves, one step at a time. We're going to tackle each one separately. This is really where the magic starts to happen, so let's focus in. First up, let's start with the oxidation half. This is the part with our friend, the gold. We're looking at how that gold, Au, reacts with cyanide, Cn-, to make that new thing, that complex. Come on, let's put all our focus right here. Okay, this process is super simple. It's just two steps. Step one, balance the atoms. So we look at the left and the right. We've got one gold atom on each side. Perfect, that's already done. But wait, see that complex on the right? It has two cyanides in it. So that means we need to put a big 2 in front of the cyanide on the left side to match. Easy, right? Okay, step 2, balance the charge. We'll just pop one little electron onto the right side, and that'll make the charges on both sides totally equal. And boom, balanced. Look at that. A beautiful, perfectly balanced equation. That's a huge win for us. Let's just double check the charge. On the left, we have 2 times -1, so that's a total of -2. On the right, we have -1 from the complex and -1 from our electron, which is also -2. It's perfect. First piece of the puzzle is officially solved. Yes. Fantastic job, everyone. You're doing great. Okay, let's keep this momentum going and move on to the second half of our puzzle, the reduction half. You know, sometimes in chemistry, you just get a little gift, and this is one of those times. The reduction of oxygen in what's called a basic solution, well, it's a super common standard half reaction. And look at this. It's already balanced for us. We don't have to do any work here. The atoms are balanced, the charge is balanced. The second piece of our puzzle is already complete. How awesome is that? Okay, this is it. This is the really exciting part. We have our two perfectly balanced puzzle pieces. Now it's time to put them together and see the final picture. Let's do this. Uh-oh. Hang on a second. We have a problem. Do you see it? Our oxidation half is only giving away 1 little electron, but our reduction half needs to take in 4 electrons. That doesn't work. It's like trying to buy something that costs $4 when you only have $1. The numbers don't match. So what in the world are we going to do? Simple. We multiply. The only way to make this work is to make the number of electrons equal on both sides. And since we need 4 electrons, we're going to take that whole entire oxidation reaction and multiply everything in it by, you guessed it, 4. And you can see exactly what that looks like right here. Before, we had 1 gold atom and it made 1 electron. After we multiply the whole thing by 4, we now have 4 gold atoms and they make 4 electrons. Now they match. The 4 electrons being lost in oxidation now perfectly match the 4 electrons being gained in reduction. This, my friends, is the golden key that unlocks the entire puzzle. Now that the electrons match, the last step is the easiest one of all. We're just going to add everything on the left side of both equations together and then add everything on the right side of both equations together. And because we have 4 electrons on the left and 4 on the right, poof, they cancel each other out. They just disappear. And there it is, the final balanced equation. Hey, does that look familiar to you? It should. It is the exact same equation we saw on that very first puzzle slide. We did it! We built the whole thing from the ground up. That is some fantastic work. But wait, we're not quite done. You know, a true master, a real pro, always checks their work. So let's do one final check just to be 100% sure we nailed it. Okay, let's run the numbers. On the left side, we have 4 gold atoms. On the right, 4 gold atoms. Check. 8 carbons on the left, 8 on the right. Check. 8 nitrogens on the left, 8 on the right. Check. 4 oxygens, 4 oxygens. Check. 4 hydrogens, 4 hydrogens. Check. And the big one, the total charge, it's -8 on the left and -8 on the right. It is absolutely perfectly balanced. We did it. Wow, that was quite a journey, wasn't it? Now, let's make sure all this amazing new knowledge sticks in your brain. It's time for a quick recap to lock it all in. Okay, so this is probably the most important question of the entire lesson. Are you ready? When you've got your 2 perfectly balanced half reactions, what is the absolute, number 1, most important rule, the golden key, to combining them the right way? This is it. It's all about the electrons. You must make the number of electrons being lost in oxidation totally equal to the number of electrons being gained in reduction. That's the whole secret. Honestly, if you just remember that one single thing, you can solve any of these puzzles, no problem. You all did such a brilliant job today. Seriously. You took a really complex-looking problem and you solved it like a total pro. So I'll leave you with a final thought. Now that you've mastered this gold standard equation, what other big, complicated things in your life could you understand better just by breaking them down into smaller, simpler parts? Think about it. Thank you so much for joining us here at the John Louis Memory School, and we can't wait to see you in the next lesson.